Right. Okay.
We'll go from there. It looks raw.
And now I've gone. Okay, so the Gaussian parametric equation. It's great to be back. Right, here we have these equations show that derived by x is bigger than 0. Well, the first thing is just a standard thing to do this, isn't it? We know, oh, this is a fancy pen. We know that faced with that option, we've got to do dx by dt and dy by dt. And this is why, don't do that, Joel. What does it even say? Hi, I'm Dave. Hi, I'm Dave. Oh, right. Dx by dt, it's a quotient, isn't it? It's a u over v thing. So we've got to do the whole v du by dx. Oh, which does it start with? Is it v du by dx minus u dv by dx, or is it the other way around? Visual display unit. Classic. So, we want to do v times du by dx. And if you differentiate t plus 2, you just get 1. Minus u, that's t plus 2, times dv by dx. And if we differentiate t plus 1, we get 1. All over v squared. T plus 1 squared. Which if we tidy that up, we've got, well, the t's disappeared, haven't we? So we've got minus 1 over t plus 1 squared. Okay. Dy by dt. I'm not going to do this as a quotient rule because that would be unnecessary. It's 2 lots of t plus 3 to the minus 1. So it's a chain rule. It differentiates the whole thing. That's minus t plus 3 to the minus 2. Times the derivative inside, which is just 1. Which is minus 2 over t plus 3 cubed squared. Right. So dy by dx is dy by dt over dt by dx. So it's that one divided by that one. So we've got minus 2 over t plus 3 squared over minus 1 over t plus 1 squared. Which gives us, well, this is, we're divided by this, so we multiply by its reciprocal.
All right.
The minuses are going to cancel out. So we've got 2 lots of t plus 1 squared over t plus 3 squared. Now, faced with that, the question did say, show that dy by dx is always bigger than 0. Have I gone out of shot now?
Yeah.
Now I'm back. How do we show that that's always greater than 0? Well, these things are both squared, aren't they? And squared things are greater than or equal to 0. So the only issue is, could it be equal to 0? But if we look back at the original question, t can't be equal to minus 1, because that would give us a 0 on the bottom of that fraction. So as t is not equal to minus 1, 2 t plus 1 squared over t plus 3 squared must be bigger than 0. That was a sneaky bit, wasn't it? Right, second part of it said, find the Cartesian equation of the curve, giving your answer in a form not involving fractions. Okay, so we've got to rearrange this. Well, part 2, we're going to start with y was 2 over t plus 3. If we rearrange that, that means t plus 3 is 2 over y. So t is 2 over y minus 3. I think that's much the easier one to start working out with, isn't it? So let's sub that into x. X is t plus 2 over t plus 1. So 2y minus 3 plus 2 over 2y minus 3 plus 1. Which gives us 2 over y minus 1 over 2 over y minus 2 is x. And if we multiply both sides by the denominator, we've got 2x over y minus 2x is 2 over y minus 1. And it did say in a form not involving fractions, so that the last thing that we would do here is multiply by y, 2x minus 2xy is 2 minus y. I kind of feel you probably want to collect things together a little bit more, but that's probably enough. I might have been inclined to write that as a slightly nicer way of presenting it. It's actually a slightly odd thing to say do it without fractions, because then I might have taken y out as a factor and written it as 2 minus 2x over 1 minus 2x, and that might have been even nicer. But anyway, that's it, that's what they want. There it is. Whew. Right. And we gave you a second question to do in this week's test, which was a curve, another parametric equations. Wow. Double whammy, and this one brings in logs. How much do we like logs? 7. Right. What did you do there, Joel? Who is that?
Paddy McGuinness.
Who?
Paddy McGuinness. It's the guy who take me out.
When do you leave? Right, so we need to find dx by dt and dy by dt. dx by dt, differentiate 9t and we get 9. Yeah, good. Differentiate 9, ln 9t, 1 over t. You could, if you want to, think of it as 9 over 9t, but it would still cancel out, wouldn't it? Differentiate this one and we get 3t squared from our t cubed. Now, ln t cubed. Well, the answer is 3 over t. There are a number of ways of justifying that. One thing you could say to yourself is that differential of the whole thing, big bear, chain rule, would be 1 over t cubed times the derivative of the inside bit, which would be 3t squared. The t squared cancels out, t leaves with 3 over t. Or you could think to yourself, this is just the same as 3 ln t, because the 3 comes down to the front. And if you differentiate 3 ln t, it's 3 times the derivative of ln t, which is 1 over t. So anyway, it's that. So dy by dx is 3t squared minus 3 over t over 9 minus 1 over t. We could spend a long time trying to tidy that up. Matthew. Or we could say it's going to be equal to 3, so let's just put it equal to 3. So 3 is 3t squared minus 3 over t over 9 minus 1 over t, which gives us 27 minus 3 over t is 3t squared minus 3 over t. At which point we notice that there's a minus 3 over t on both sides, so that cancels itself out. We can divide by 3, leaving us with 9 equals t squared, so t is plus or minus 3. The question said show that there is only one value and find this value. And then we look back to the original equation and realise it was all about logs. And logs, you must put a positive value into it. It's only defined for positive values. So right from the start of the question, implied in the way that this was set up, is that t is greater than 0. If t is greater than 0, the only value that we can accept is t equals 3. That was it. And that's maths.